Hello, 7th graders. Today we're going to be learning how to calculate the probability of a compound event. A compound event is simply two things happening at once. So we have two events, maybe rolling a dice, flipping a coin, maybe flipping two coins. We're calculating the probability of outcomes considering both experiments. Okay, so let's investigate. What is the sample space for flipping a coin? Well, we know the sample space is just heads or tails. When we're using our coins in class, it is red or yellow. So if we flip two coins, you have heads and tails on both sides. This is how you would use a table to find the sample space. You could also use a tree diagram. What that means is you would have heads, you would have tails, and then this would represent your first flip. So then your second flip, you could have heads, tails, or heads, heads, and then you could have tails, tails, or tails, heads. So that would be a tree diagram for 2 times. Oh, this says 3 times. Okay. So then from each of these, you would have another tails, heads, tails, heads, tails, heads. It gets kind of a lot when we get out there. Fun fact, you can find the total number of outcomes by counting how many outcomes you have in that last roll. So there are 2, 4, 6, 8 possible outcomes. Flipping 3 coins or flipping a coin 3 times. All right, how does the number of outcomes for each flip in exercise 2 and 3 relate to the total number of outcomes? Well, in exercise 2, there's only 4 outcomes. And in 3, there were 8. Notice we multiplied by 2. So when we flip 1 coin, we have 2 outcomes. When we flip 2 coins, we have 4, and 3 is 8. If we flipped 4 coins, how many outcomes do you think there would be? If you said 16, you are correct. Notice it's multiplying by 2. Okay, does the relationship in exercise 4 hold true for each combination? Lock. Wheel 1, 0 through 9. Wheel 2, 0 through 9. Wheel 3, 0 through 9. Well, given that this is a 3-digit number, we could have any number between 0, 0, 0 and 999, which is 1,000 different outcomes, which is the same as 10 times 10 times 10. So yes, the relationship in exercise 4 does hold true. If I have 2 different experiments, and I'm doing them both at once, I can take the number of outcomes for both experiments, multiply them, and get my total outcomes for the compound experiment. All right, so same here. There were 10 numbers. A through J is 10 letters. K through T is another 10 letters. And then we have 10 here. So this one should have 10,000 outcomes. Now with heads and tails and number outcomes, sometimes it's easier to do a table or do it the math way. However, when you have something like sandwiches, where there are words of your outcomes, a tree diagram might be the easiest way to find a sample space. So looking at this example, you randomly choose a bread and a type of sandwich from the menu. How many different sandwiches are possible? Well, there are 2 types of bread, and then there are 4 types of sandwiches. So we have our wheat bread with all 4 types of sandwiches, and then we have our sourdough bread with our 4 types of sandwiches. So there are 8 different possible sandwiches because there were 8 different outcomes in the sample space. So the answer is 8. Okay, what if the sandwich shop adds a multi-grain bread? Now there would be 3 breads and 4 sandwiches. We could make a whole nother diagram, so we could add our multi-grain bread and have ham, turkey, steak, chicken. Notice there's another 4. 8 plus 4 is 12 total sandwiches. Or we could have just done 3 times 4. 3 types of bread, 4 types of sandwiches, 12 sandwiches possible. Okay, number 2, you randomly choose a flower and ornament for a gift. Find the sample space. How many different gifts are possible? There are 3 types of flowers and 2 types of ornaments, so there should be 6 different gifts possible. Okay, so the fancy term for multiplying the number of outcomes in each separate event is called the fundamental counting principle. If event M has M possible outcomes and event N has N possible outcomes, if you make those a compound event, you can do M times N to find the total number of outcomes. Basically, if you have a compound event of 2 different events, multiply those 2 separate outcomes to find the total outcomes of the compound event. Okay, example 2. Find the total number of possible outcomes for flipping a coin and rolling a 6-sided dice. There are 2 outcomes when you flip a coin. There are 6 outcomes when you roll a dice. 2 times 6 is 12 possible outcomes. We could also write all possible outcomes with heads in one row and tails in another row, where we would have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, and then we would have tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. Notice again, there are 12 outcomes. All right. Pause the video, see if you can do number 3 and 4, and then play it back to see if you got it right. All right, number 3 says find the total number of possible outcomes of spinning the spinner and randomly choosing a number 1 to 5. 1 to 5 is 5 numbers. There are 4 outcomes on the spinner, so there should be 20 outcomes possible. Now that was using the fundamental counting principle, so we can skip 4. If you listed it out or did a sample space, you should have also got 20 total outcomes. All right, so now that we know how to find the sample space or the total number of outcomes for a compound event, let's learn how to find the actual probability. Again, a compound event consists of 2 or more events. Okay, you randomly draw one of the marbles shown from a bag. You replace it and randomly draw a second marble. What is the probability it is blue both times? Well, this side is representing our first draw. This side is representing our second draw. Because you put the blue marble back, it has a 1/4 probability both times. Notice there's only 1 blue out of 16 total. So there's 1 favorable outcome out of 16 total. So the probability is 1/16 or 6.25%. Now, real quick, another way to do this, we know the probability the first time was 1/4. We know the probability the second time was also 1/4. So just like you can take the number of outcomes and multiply them to find the total number of outcomes, you can also take the probabilities and multiply those. So 1/4 times 1/4 would also give us 1/16. All right, pause the video, see if you can do these 3 at the bottom, and then play it back to see if you got it right. So 2 marbles that are not green would be 3/4 times 3/4, which is 9/16. Drawing at least 1 marble that is red. Well, this one I'm going to refer to the table, and I'm going to highlight these like this. So at least 1 marble that is red. I'm going to highlight any with an R in it, which would be these, which would be these. So that should be 7 outcomes out of the 16. Okay, drawing exactly 1 blue marble. So again, we're going to highlight our outcomes. These ones have exactly 1 blue. These ones have exactly 1 blue. I'm not counting the double blue because that would be 2 blue marbles. So this was 6 out of 16, which is also 3/8. All right, last example. On a game show, you randomly choose 1 box from each pair of boxes shown. In each pair, 1 box contains a prize and the other does not. Out of 800 attempts, how many times do you expect to win at least 1 prize? Notice they made a tree diagram of all the possible outcomes. So P is representing prize, N is representing no prize. So there's really only one scenario where you have no prizes out of all the possible outcomes. So let's take note of how many outcomes there are. There are 8 possible outcomes. So this is only 1/8 probability of no prize. Now remember our formula for predictions that we learned in our last notes. The prediction is the probability times the total. So to predict how many do have a prize, I'm going to take 7/8 and I'm going to multiply by 800. So that's going to be 700 times, but again, that probability was just 7/8, which is 87.5%. All right. Okay, last thing you have to do, you flip a coin 3 times, predict the number of times at least 2 coins will land heads up. We repeat the experiment 100 times. So first I need to think of the outcomes that are favorable. The outcomes that would give me at least 2 coins with heads up. I could have tails, heads, heads. I could have tails, heads, heads, tails, heads. Or I could have heads, heads, tails. Now it did say at least 2, so I could also have heads, heads, heads. All right, we know the number of outcomes with 2 coins 3 times is going to be 2 times 2 times 2, which is 8 total outcomes. There are 4 favorable outcomes out of 8. So I'm going to take that probability, which is 1/2. We're multiplying by 100, so we don't have to simplify, but it should be 50 times out of 100. You would predict at least 2 coins to land heads up. All right, please see Canvas to see what the rest of your assignment is for today.